Hello, everyone. We are Flukes Plays with our age identification project. Computer vision was first attempted in the early 1960s, with researchers attempting to get a computer to see images as more than just pixels. Now, 60 years later, our team has developed a prototype computer vision model that can tell you your general age. We created this model over the course of 3 weeks and have encountered many roadblocks along the way. At first, we were considering identifying different medicinal pills or finding the difference between certain foods, but we felt that overall, the practicality of an age identifier was needed. When treating patients without identification, doctors would be able to tell a patient's age and help them on a path to recovery using care specifically designed for their age group. Age is also important for age is an important factor for criminal identification. The police could use estimated age to have a more accurate profile to investigate or release to the public. In this product, we mainly used Python, HTML, and CSS to begin achieving this goal, and incorporated the YOLO v5 model to detect age. To divide up the work, team members Vivian and Zalea took the back end of the project and incorporated our model into our website, while the designing was done by Tony, Colin, Lennon, and Sanjiv. The result was the website you see before you. The main button on the home page lets you upload an image and run it through our model. Below that, the How It Works page describes the steps to operate the website and AI. Going further down, there are some specifics about our project and what we did to accomplish it. Then the journey is described, which tells the story of how we made our model in 3 weeks. Finally, there's our team page, which you've already seen, and it has our images and summaries. And here is Tony with more information about our model.
Hi, I'm Tony. I'm going to be talking about our data set. So our data set contained around 3,000 images, all split into ranges of different intervals. The ranges go from 0 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, and finally 60 plus. In addition to the age ranges, our data set also includes backgrounds to help the AI recognize what is and isn't a face. The two main ways we found our images for our data were through online databases and web scraping. Kaggle provided a database with thousands of images of faces, and web scraping, a process of extracting a certain amount of Google images from a search result, was used to add even more images. We went through all the images, taking out the blurry and watermarked ones, splitting them into age groups, and ensuring that there was no bias towards a skin tone or gender in the process. We then uploaded the data to RoboFlow, annotating and applying augmentation to the data. Data augmentation is a technique to artificially expand a data set by creating variants. It also helps reduce overfitting. The two common augmentations we used during our training were crop and blur. And I'm going to pass it down to Sanjiv, who's going to talk more about the model we used.
So our model of choice was YOLO V5S, which was a good middle ground because it had a less load on the GPU and the runtime so that our Google Colab was able to run without issues and was still able to keep a high level of accuracy. For the parameters that we chose, we went with the image size of 512 because that was the highest we could go without running into issues with the Colab RAM. And for the batch size, we went with 64, which was the recommended number on the YOLO V5 GitHub page. And for the number of epochs, we went with 400. So originally, we started with 300, which was the baseline on the GitHub. But we moved this number up slightly every single time because there were no signs of overfitting, and we got to our final number at 400. Now I'm going to pass it to Colin to talk about the results.
All right, so I'm Colin, and I'm going to talk about some statistics. This graph is known as a confusion matrix. On the x-axis, it displays the true values of each picture in our data set, and on the y-axis, it displays the percentage of guesses for that age range. The overall accuracy of each age range is about 60%, and we can see from this graph that confusion usually fell into the neighboring age ranges. For example, the 41 to 50 age range was most confused with 31 to 40 and 51 to 60. And this is known as a PR curve. It is another more specific measurement of accuracy. On the y-axis, we have precision, and on the x-axis, we have recall. We will ideally want the highest possible value for both the precision and recall values. However, we can see that as recall gets larger, precision goes down. This indicates that as we had less false negatives, we started gaining more false positives. And now I'm going to pass it on to Zalea.
So to start our website, we first downloaded a template from Bootstrap, and our front-end team chose a color theme and worked on customizing the template. And the back-end team created the results page and connected the home and results page using Flask and connected our model to the website. So here you can just click the upload button and then choose an image to upload, and then it'll take you to the results page. And then it tells you how old it thinks the person in the image is. And then you can upload another picture. And one thing that we found with our model is that our model is more accurate when the pictures only have the face up close. So for example, this picture is of a baby and it accurately identified that it's 0 to 5. But if you upload the full like body image, it got confused. And so this is because a lot of our images in the data set were only of the face. So that's why sometimes it gets confused. Now I'm going to pass it over to Vivian to talk about future steps and improvement.
In the future, we would like to add more labels by splitting up the age range into more specific categories. And in addition to that, we want to work on including full body images in the data set and training our model more in general. Some other functions to consider adding are object tracking so that our model will be able to recognize moving objects. This would allow it to predict the age of people in videos and have practical uses for criminal identification, since it would be helpful for detecting the age of suspects in security footage. Thanks for listening to our presentation.